This lesson is about the distance formula. Our learning target today says I can use the Pythagorean theorem to find the distance between 2 points in a coordinate system. Our essential question says how do you find the distance between any 2 points? We have one new vocab word today. It's the distance formula. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So it looks like it's really complicated, but once you get the hang of it, it's not that bad to work with, and it's actually very similar to the Pythagorean theorem. So this is the formula. This distance formula can find the distance between any 2 points. And remember, those points are x1, y1, and x2, y2. So the little ones represent the first ordered pair, and the little twos represent the second ordered pair. And every ordered pair has an x coordinate followed by a y coordinate. All right, so our first example, I'm going to label the points first, x1, y1, and x2, y2. And then I am hopefully going to move this down. There we go. Okay, so now working with this distance formula, it's a big square root. We have 2 sets of parentheses, an addition sign, 2 exponents, 2 subtraction signs. So I always like to start out by filling in that part of the distance formula because that part is always there. Now I'm going to substitute for x2. So here's my x2. x2 is 1, and then x1 is 5. Then y2 is 8, and y1 is 3. So I just changed colors to show you where I replaced those numbers. Now it's just a matter of using the order of operations. So underneath the square root, we have parentheses, 1 minus 5, and 8 minus 3. 1 minus 5 is negative 4, 8 minus 3 is 5. Then we have exponents next. Negative 4 squared is positive 16. 5 squared is positive 25. Then I can add those two together. And the last thing I do is use a calculator to take the square root of 41. And we're rounding to the nearest 10. So it's approximately 6.4. So that would be the shortest distance between those 2 points on the coordinate plane. Our next example, same thing. So x1, y1, x2, y2. And the part of my distance formula that's always there. You don't need to memorize this distance formula. It will be given to you on your test and on your MCA. You have to know how to use it though. So I start with x2, negative 3, and x1, 4, and then y2, negative 1, y1, 2. So, parentheses, negative 3 minus 4 is negative 7, and negative 1 minus 2 is negative 3. If I square each of these, negative 7 squared is 49, and negative 3 squared is 9, They add up to 58. Remember, when you square something, a negative times a negative is a positive. So squaring something will always give you positive numbers at this step that I just underlined. Now, the square root of 58, if I round it to the nearest tenth, is 7.6. Third one, hopefully you're getting the hang of it. XY first order pair and XY second order pair. Okay, so x2 this time, -4, minus x1, 3, and then y2 is 5, minus y1, -7. Okay, so on this one, the first set of parentheses, -4 minus 3 is -7. And on the second set, 5 minus -7. Remember that that double negative turns into a plus. If you take away the negative, it's a positive. So 5 plus 7 is 12. So -7 squared is 49, and 12 squared is 144. And if I add those together, I get 193. And the square root of 193 is about 13.9. Remember, on my calculators, most of them that I have in the classroom, to use the square root key, it's the second function of x squared. So you have to push the button that says second first, then push the button that says x squared, and then enter in your number. Last one of these, before we switch to some graphing problems. So x2 this time is -5. x1 is -7. So that one's turning into a plus. And then y2, -8. y1, -2. So again, that one is turning into a plus. So -5 plus 7 is +2 squared. Plus -8 plus 2 is -6 squared. So 2 squared is 4, -6 squared is 36. So these add up to 40, and then the square root of 40 is approximately 6.3. Okay, so that's 4 examples of taking the ordered pairs and substituting them into the distance formula. Now we're going to shift to graphs. If you are looking at a graph, I do not typically recommend using the distance formula. I instead want you to recognize that if the dots lie on a horizontal or vertical line, you can count the distance. And if they lie on a diagonal line, you could use the Pythagorean Theorem. And it's quicker than using the distance formula. So these 2 points, the distance that the point on the left is from the one on the right, I can count 1, 2, 3, 4, 5, 6, 7. So that distance is just 7. Remember, distance is always positive, so it doesn't matter, here we go, it doesn't matter which point you start at. So this one, if I start at the point on the top, 1, 2, 3, 4, 5, 6. 6 units. The distance will never be a negative. Remember, when you measure distance, like with a ruler, tape measure, anything like that, there will never be negative numbers on it. Okay, now we've got a diagonal distance. When you are trying to measure a diagonal distance, you're not going to be able to count it. What you can do, though, is turn it into a right triangle. So if I go straight down and straight across, I've got a right triangle. then I can count both of the legs. So one of them has to be horizontal and the other one vertical. So this one is 2, and then the bottom one is 5. And the side I'm looking for is the diagonal one, or the hypotenuse. So if I use the Pythagorean theorem, it's going to be a lot quicker than writing the ordered pairs and using the distance formula. So 5 squared plus 2 squared equals the distance I'm looking for squared. 5 squared is 25, and 2 squared is 4. When they're on the same side, you can add them together. And then remember, with our Pythagorean theorem, the last step is to take the square root. So the square root of 29 is about 5.4. So my distance is about 5.4. And that makes sense because the hypotenuse has to be the longest side in the triangle. So it's longer than the 2 and the 5. Next one, we'll do the same thing. Turn this into a right triangle on the graph. So the distance we're looking for is here. If I go straight down and straight over, I've got my right triangle. This time, the bottom is 3 and the side is 8. So 3 squared plus 8 squared equals c squared. 9 plus 64 equals c squared. I can add them together to get 73. And then the last step again is the square root. So the square root of 73 is about 8.5. So you can use the distance formula if you want to write ordered pairs for points that are graphed, or you can use the Pythagorean theorem.